Thank you, Willie, and I'm delighted to be here today. Thank you to the Swiss Innovation Forum for having me. I look forward to telling you more about this research vision that Willie mentioned to us. My name is Ariel Ekblaw. I am the director of the MIT Space Exploration Initiative, and I'm here today to paint a picture for you, not just of the work that we are doing at MIT, but of the state of innovation and opportunities across the field of space exploration. Something that we should all know and appreciate is how close we are now to the cusp of interplanetary civilization. So as humans, we're reaching this point where we are beginning to plan seriously for life off of Earth, whether it's in commercial space stations in orbit, on the surface of the moon, or on the surface of Mars. And so I look forward to showing you some of the stories and the research and the work that's going to get us there. When you think about the current status of life in orbit, so life and human life being supported off of the surface of the Earth, we are, of course, most familiar with the International Space Station, which is an international collaboration across many different countries and has been continuously inhabited now for many, many years. In fact, people who were born after the year 2000 have not known a time when there were not humans living in space. But we're also at this transition point where space has been primarily the domain of military, defense, and governments. And now we're seeing this burgeoning evolution of commercial interest in space. And so on the right-hand side of my screen, I hope you see the Axiom Space Station, which is a prospective space station. And it's a company in the United States that's thinking about sending an entirely new space station to orbit. So soon, the International Space Station may have a neighbor. When we think a little bit beyond just low Earth orbit, which is this near Earth cocoon around the surface of the Earth, we come to the inevitable question, what is the plan for the moon? Of course, we in 1969 landed a human on the moon, and many other countries have been involved since in terms of the missions to the moon and rovers and science. But NASA's Artemis program here in the United States is planning to return to the moon with human life, and we're very excited about NASA's plans to have the first woman land on the surface of the moon sometime after or around 2024. And again, international partnerships are so important here, and we're really working with an international community. The Artemis Accords have just been shared earlier this year, outlining how we will, across humanity, be returning and planning for this presence on the lunar surface. And of course, some of you may have also heard about Elon Musk and SpaceX, and not just SpaceX, but also other companies that are thinking about going even further. So how would we actually support human life on the surface of Mars? And of course, this is a big challenge, but one that we are very excited to see that the work that we're doing, that they're doing, these different companies. And then we are also contributing to this future by thinking about not just the rockets that get us there, but this suite of human technologies, all of the other products and tools and experiences that we'll want as humans as we're living in these very different and often harsh and extreme contexts. But our mission in the Space Exploration Initiative, so back to MIT now, our mission is to be designing, prototyping, and building these artifacts of a space future that would really delight humanity, that would make us want to live in this extreme environment. So while NASA and ESA, the European Space Agency, and Jeff Bezos and Elon Musk and others may be thinking about the rockets to get us there, wherever there may be, Mars, Moon, or beyond, we are focused on the human lived experience of space. Our long-term focus, for anyone who may be familiar with Star Trek, is Starfleet Academy, and it was where the young cadets would go to learn to be space captains and space doctors and space psychologists, all of the different elements of a space crew. But fundamentally, it was also where the technology of the Enterprise, the spaceship in the series, it was where the technology of the Enterprise was built. And so we're very excited to have this special moment in the space industry, as you've seen in the last few slides, all of these changes that are coming to bring us to new locations for life in space, coupled with the academic rigor of MIT, the Massachusetts Institute of Technology, and this opportunity to found perhaps a real-life Starfleet Academy. This is the team. I'm very fortunate to lead a wonderful team. We have 10 core staff members, but then also over 50 graduate students, staff, and faculty. And what's really special about this team is that we're not all scientists and engineers like myself. I was trained as a physicist and then later did my PhD in an aerospace engineering domain. We also have artists and designers and ethicists and people that bring a really rich envisioning for the future of life in space to the team. And I think that this is so important when we think about democratizing access to space exploration. We want it to be a future that reflects the dreams and the interests of all of us. And to make that happen, we need to be able to have a diverse set of ideas and a diverse team working in this endeavor. You also see that we have some really fantastic leadership at MIT, and perhaps we can talk a little bit more about what this is like to lead a creative studio team for space exploration when we get to the discussion later. In terms of our ecosystem, what makes this work, what makes this happen? Of course, it starts with the 50 plus graduate students, staff, and faculty who are the researchers that contribute new ideas in our portfolio of research. We also work quite closely with over 60 different member companies. So the MIT Media Lab is funded by a consortium of industry partners. And I think this is particularly interesting perhaps for the Swiss innovation audience, thinking about what can your company or your entrepreneurial endeavor plan for in the future of space exploration. Perhaps low Earth orbit can be thought of as a new emerging market, and there are all kinds of interesting economic opportunities that we're trying as a space industry to spin up, both in the near space, so in low Earth orbit, and out to the moon. Beyond the member companies, we collaborate really extensively across MIT and with several of the major international space agencies like NASA, ESA, and JAXA, Japanese Space Agency. And then we also work with a cohort of different new space age companies. So these are innovative startups that are thinking about everything from the future of space agriculture to space tourism. And finally, all of this ecosystem contributes to over 40 different in-house research projects. Now, today I don't have time to tell you about all of them, but I will be in subsequent slides giving you a little peek of some of the space habitat research that we're working on. And so just to recap, what we really think is our mission here is training the space generation. This is a photograph of an inside of a parabolic flight. So this is a plane that simulates microgravity. It does what you'd want a plane never to do. It pitches very steeply upward at 45 degrees, noses over, and then pitches at the ground, points at the ground at 45 degrees. And it repeats that parabolic arc 20 to 30 times in the sky. So it's like a roller coaster in the sky. But at the top of those arcs, you get a few beautiful seconds of microgravity. And here's one of our students training with retired astronaut Katie Coleman, who we were delighted to have come with us on this particular flight. And this is where we test our research for the future of life in space. We also care deeply about democratizing access to space. This is Annie Liu, an artist who brings an entirely different perspective to the nature of her projects with us when she was working with us here in 2017. And it's so important that we have both deep tech, science and engineering work, but also design and art and architecture so that we can weave the tapestry, weave these different elements together into the future of life in space. Our launch pipeline moves from this plane-based experience of microgravity that I shared, the zero-G flight, through to rocket launches. So we like to say that you're not a real space program if you're not actively launching into space. And these are the different ways that we get our research out there. So we move from the parabolic flights, the planes, to various different types of rocket launches, suborbital and orbital. We were very pleased to have 5 payloads studied aboard the International Space Station for over 30 days in orbit earlier this year, and we're already planning with our close partner NanoRacks for another mission next year to the International Space Station. And then now we're also beginning to plan the early stages of our own mission to the moon, likely in collaboration with Blue Origin and under a memorandum of understanding that MIT and Blue Origin are exploring together. Now for a research highlight, and of course I wish I could tell you about all 40 projects on the portfolio, but we'll stick to just one today, and I hope if you are interested that you'll reach out to us and explore our website for the other interesting projects that we pursue. So my personal research passion is in building the habitats that will ensconce our spacefaring species. And so this means being able to build in microgravity contexts, whether we're thinking about the future of space cities, and also on planetary bodies on surfaces like the Moon and Mars. Now, my expertise is in self-assembly. So you can imagine, say, like a set of Legos or IKEA furniture that builds itself in orbit. So now what we do is we take these tiles that you can see in the image and we create a sphere, and the tiles self-assemble. So astronauts do not need to go out for maintenance or for assembly. These tiles, using very powerful magnets, are able to bring themselves in together and self-assemble a structure. Now, we've tested this work in miniature, so in small prototypes in the lab, and we've also tested it in small prototypes on the International Space Station. It was one of the 5 payloads that I spoke about just a moment ago. And what we're excited to do now is scale up this research to the habitat scale for self-assembling space architecture in orbit. I'll now just play a short video and narrate over it briefly while you see this happening. This is the concept of how these tiles would be released from a rocket. A rocket payload fairing opens in orbit and allows these tiles to come out. They have magnets on their bonding edges and they begin to snap together. They're like puzzle pieces coming together autonomously in orbit. This is a big focus of our work, integrating artificial intelligence and autonomy into the creation of space habitat so that they can truly build themselves. And here you see that spherical-like shape. It's actually a buckyball or a Buckminster Fullerene geometry coming together. And then multiple modules can also dock once they've individually self-assembled. The entire module can come together and dock to form a larger space station. I think it's so important, especially if we're talking to any young people in the audience who might be thinking about their own careers in technology and innovation, to understand just how much work goes into a technological vision like this. So this is just a mosaic of many of our different hardware test platforms and the circuitry and the engineering and the mechanical design that goes into testing out an idea like this. You can see in the middle there on the right, our launch with Blue Origin. This was over a year and a half ago as we're building up to the International Space Station launch. And then in the bottom row, we also work extensively with mathematical modeling and simulation, and we chose a game design engine, so something that you might see within a VR headset, to be able to visualize not only the rigorous physics fundamentals of how we bring objects together while they're floating in microgravity, so thinking about how they collide and how the magnetic forces work, but then also rendering it in a visual way so that we can have a story to tell about the work. And at the Space Exploration Initiative, we care really about all of these different dimensions of presenting and discussing the innovative qualities of our research. I'll just close by saying we hope you will join us. We host a flagship event every March. It's called Beyond the Cradle, where our cradle is this cradle of humanity on Earth where we have begun our civilization. And we bring together 60 leading space visionaries. So everything from international astronauts from all around the world to the CEOs of leading space companies to the sci-fi authors and Hollywood producers of science fiction films, because we really believe in this mission of co-designing the future of space with all of these different creative voices in attendance. And we make it publicly available via a live stream every year, and we hope you'll join us if we're able to host this again in March. And with that, I'll close and just say you can reach out to us here at our Twitter handle or investigate more of our work on the website. And I'm really looking forward to the conversation that we'll have with Willy Benz. Thank you so much.